Because again, who the heck wants to do product rule with this, right? Come on, guys. I mean, this is like crazy. Who the heck wants to do problems like this? But if we recognize that we can take the ln of y on both sides, this actually doesn't work out to be that bad. Because then we can just take the product of each of them. I'm sorry, we can take the derivative of each of them separately, right? Which makes some sense. I can take the derivative there, here. I can take the derivative here. And I can take the derivative of that, right? So by using logarithm, what that allows you to do is do them separately. Now, we want to take the derivative. So we're going to take the derivative of with respect to x. So rather than writing down a new line, I'm just going to kind of throw it in there on both sides, sneak it in. So I'm going to take d over dx. So again, remember, this is almost should be commonplace now. 1 over y dy dx. Oh, what am I doing? Well, sorry about that. I did get a little ahead of myself, didn't I? Before we take the derivative here, let's use the property of logarithms. OK, now if I'm going to do d over dx, I'll do ln of y. So now, rather than writing this out. So we have that. Now let's take the derivative with respect to x. And I'll use blue so you guys can see that I added that in there. Right? You got to make sure you do it to every term. Be careful with that. So d over dx of ln of y is 1 over y dy dx. dy dx of ln of x to the 2/5. That's going to be 2/5. What am I doing? It's going to be 1 over x to the 2/5 times the derivative of my inside function, which is going to be times times x to the minus 5 over 5, which would be negative 3/5. Plus over here, I'm going to have 1 over x squared plus 8 times 2x plus the derivative of ln e to the x. Now, again, we could I could simplify that before I even took the derivative, right? Because if I basically simplify this ln of e raised to the x squared minus thing, I could really just rewrite that as, using our rules of exponents, we could just write it as x squared plus x, right? So really, I'm taking d over dx of x squared plus x, because I'm going to simplify before I take the derivative. You could take the derivative. You're going to get the same answer, but it's a little bit extra work. So the derivative here would be 2x plus 1. All right, so the only thing I see that I kind of need to clean up here a little bit is this first one. We have 1 over x to the 2/5 times 2 over 5 times x to the negative 3/5. We'll want to multiply by y as well. So let's do dy over dx equals y, which is some crazy term. T to the x squared plus x. OK, so that's what y is, right? So I'm just replacing y, because you had to multiply y on both sides. Right? Is everybody following me with that? To solve for dy dx, you got to multiply by y. OK, so I just rewrite the y in the front. And let's simplify this here. 2 is going to go up top. 5 is going to go on the bottom. So therefore, this is x to the negative 3/2. So that's going to go down below. So therefore, this is really, so it's x to the 2/5 times x to the negative 3/5, right? So if I bring that down in the denominator, I have, so therefore I'm going to have x 1 over x to the 2/5 times x to the positive 3/5. Yes? No? This is negative, so it needs to go into the denominator. So therefore, it's positive. 2/5 times 3/5, you're going to add them, though. So it's going to be x to the 6/5. And then that should be good. Over here, we're just going to multiply that across. Huh? Oh, 3. Of course, yes. I even thought of, I don't know what the heck I say. Yes, it's 1. Thank you. And then 2x plus 1. That's what these problems will do to you. They make you go crazy.